Okay. All right, so quadratic formula, look it up. It's a good time. Do the numerator before you do anything with the denominator. Okay, so when you're factoring this, just ignore the equal 0 just for right now when we talk about this. So what are the factors of negative 20 that add up to a negative 1? So we're looking for the factors of negative 20. Here, let me do the first one for you. Negative 1 and positive 20. Ooh, let me do the next one for you. So negative 5 and 4, right? So the faster we get at these factor pairs, this one works out really nice because that adds up to the coefficient of negative 1 right here. So what we're going to do is we're going to put our two binomials. One's going to be x minus 5, and one's going to be x plus 4. And because it's an equation, you have to put the equal 0. If you forget this in this line, that's a half mark deduction. So anytime you lose that equal sign and change it into an expression, you can't do that. So then we're going to set each factor equal to 0. And we're going to have x equals 5 and x equals negative 4. So that's nice and fast, right? And with me not talking, and can you skip from this step to this step? Of course. Do you have to write this stuff? No, you don't. So I think as we become more efficient with it, we can start skipping steps. So now let's move on to part B, where we're going to use the quadratic formula. FYI, both will give you the exact same answers. So if I choose to factor it and you choose to use the quadratic formula, great, we both get to the same solution. Okay, so let's talk about this for a second. A minus x minus 20 equals 0. Okay, so this is in standard form. You guys would agree with me. It's actually in general form because it's equal to 0, but this is in standard form. So what is my a value? It's always the coefficient, but yeah, it's the 1 in front of the x squared. So it's invisible, so we know it's a 1. What's the b value? Negative 1. And the c value? Negative 20. So you don't have to do that in the beginning, but sometimes it helps you locate where the numbers are, and it makes it a little bit simpler. Again, anytime that I start with a new formula, I'm going to always write that formula out first. Now I want to be, so the variable I'm using here is x, so my quadratic formula starts with an x. If I had used a here, my quadratic formula would start with an a. Does that make sense to everybody? Don't put different variables in this. So a equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, as I'm learning a new formula, I'm always going to write it out. I find sometimes people forget the squared a lot in this formula, so please don't lose that. And it is on your formula sheet, and you can get a tattoo of it if you want. All right, so this is kind of like our secret formula, that negative b. So if our b is a negative 1, what is it here? It's a positive 1. 1 plus or minus the square root of negative 1 squared minus 4 times a was 1, and c is negative 20, all over 2 times 1. Not a lot of hard math here, folks. Not a lot of hard math, but math nonetheless. So x is equal to 1 plus or minus 1. Now here's the thing. You can do it one of two ways. You can say subtract and then just look at these. And 4 times a negative 20 is a negative 80 all over 2. 1 plus or minus. So when we have a subtract a negative, what do? Add them. So it's going to be 81 over 2. Okay, so looks very different. We're not done our math yet. Anybody excited about the 81? Well, it's a perfect square, right? So I can square root it pretty easily. So this is where we break into two separate formulas. So we're going to have x equals 1 plus root 81 over 2, and x equals 1 minus root 81 over 2. Oh geez, I haven't left myself enough room. I'm going to carry over to here just so I have some space. You guys okay with that? So you see that this, one goes here and one goes there. So this is where it splits into two. I'm going to scooch over here for a second. So what's the square root of 81? 9. So 1 plus 9 divided by 2. And I'm going to have x equals 1 minus 9 divided by 2. So x equals 10 divided by 2. What is that? What's 10 divided by 2, folks? 5. Beautiful. You know how I told you never to work across the page? And here I am working across the page. And this one's going to be x equals negative 8 divided by 2. And that's going to give me a negative 4. And those are the exact same answers as we got by factoring. And in this case, which one was a lot less work? The factoring, right? It won't always be that way, especially when we're dealing with decimals. Quadratic formula is the only way to go with that. I will let you guys in on a little secret, because that's what we're here for. Okay, so there are all kinds of apps out there that have the quadratic formula in them. So I have one called Quadratic. It was free. And I can actually just put in my A, B values. So A was 1, B was negative 1, and C was negative 20. And so you see that the formula shows up there. That's the way it should look. And I say solve the equation, and it tells me what my x values are. Some will actually show you every step. And obviously PhotoMath will do that too. It shows me what the factors are, if there are factors of it. And it shows me this D is called the discriminant, and that's what we're learning about tomorrow, is the discriminant. So this one here, it was free. It's just a quick way for me to check my answers to make sure that I'm doing it correctly. Obviously, you won't have these on your quiz or your tests or anything like that, but this is to help you feel more comfortable using the formula. Yeah? It's just called quadratic. It's really not that exciting. It shows a parabola and it says x squared and it's called quadratic and it was free. There's lots of other ones out there too that will show you all the steps. I'm not saying this is the best one. This is just one that I found that I used. All right, so there you go. There's my phone. Again, like use the tools that will help you, but don't rely on them to do your work for you. It's kind of like copying somebody's essay. Like you're going to get caught and you will have learned nothing from it and then you'll get 0 anyway. So it's just a chance to check it. I'm not here to, I would use all the resources available to you, but just know you can't obviously use your phones on the quiz or test. Okay, easy peasy. Example number 2. So we could try to factor this one. I'm trying to, so what I go through in my head, if you're wondering what goes through my head, probably you don't want to know. But what I'm going to do here is I'm going to go, because that's the first step of complex factoring. First of all, I looked at it and said, can I common factor out that 2? And the answer is no, because 11 I can't. So 2 times 11 is 22. It's positive, but my b is negative. My b is negative, so I know that my 2 values, my 2 factors, have to both be negatives. So I would have to have negative 1 and negative 22. Well, that does not give me negative 10. Negative 2 and negative 11. Does that help? Are there any other factors? No, that's it. So right away, I know it's something I can't do with factoring. I haven't invested a lot of time in it. I've just kind of checked it. So I'm going to go ahead and I'm going to use my quadratic formula. Would you guys like to try setting up the quadratic formula without me? Not yet? Okay, watch it one more time. So my A value is 2. My B value is -10. My C value is +11. Again, you don't have to write this down. It is not required. It's just a chance for you to like pull that information out because it's what you're going to use in the formula. So when I'm learning a new formula, I always write it out. And I repeat myself ad nauseum, and I know it's annoying, but I'm hoping that it pops into your head when you are doing a test or quiz on your own. Okay, my B value is negative, so in the formula it's going to be, and it's only going to be positive here. This one will be negative, but you're going to square it, so it's kind of going to get rid of that negative. So 10 plus or minus -10 squared minus 4 times 2 times 11 all over 2 times 2. And again, if you're looking at this, just grab my highlighter. I'm looking at it as a subtraction. +4 times +2 times +11 is going to give me a +88. Was that a question? No? Yes? Math magic? Am I going too fast? Nobody's screaming. This is a good sign. That's going to be 12. Okay, so we've simplified it. Is 12 a perfect square? No, it is not. It's not a perfect square. We can reduce that radical if we wanted to, and we will a little bit more, but we're going to go into decimals for this one. So this is where it splits. Splits into two equations here. So I'm going to have x equals 10 plus root 12 over 4, and x equals 10 minus root 12 over 4. I'm going to be honest with you, I don't show the next couple of steps, I do them all in my calculator. So remember that fractions, it implies that you have to do the numerator first before you do the division, okay? So it's like having brackets, but they're not stated there, it's implied. So I'm using my handy dandy calculator. And you can do it one of two ways. You guys got to figure out what works best in your calculator. I can do root 12 and figure out what that is. That's a nice ugly decimal. And then I'm just going to add 10 to it. And so here's the deal, is that you never round in your equations. So if you write this out, you got to write out all the decimals. And then I'm going to divide that by 4. And what decimal place do you think we should round to? 2 or 3? 2? We like 2? Okay. So my first x-intercept is going to be at a positive 3.37. Now, the question is can you do it in your calculator all in one step? And in my calculator, I can. But I have to use brackets. So I just want to show you this. So bracket 10 plus the square root of 12. I need to get out from under my root sign, and then I close my brackets, and then I say divide by 4. And I get the exact same answer. So I guess my question is how comfortable do you feel with your technology? Could you do it all in one step, or are you more comfortable with doing it step by step and writing it down? Honestly, this is a personal preference. This is not, you must do it my way. This is whatever works best for you. All right, okay. So now we're gonna have x equals 10 minus root 12, and root 12 is this long decimal here. And again, we don't round in the equation, we use all the decimal places. 3, 4, 6, 4, 0, 3, 4, 6, 4, 1. I think that would be 1, 1, 0, 1, 6, 1, 5. Holy Hannah, that's a lot. And then that's all divided by 4. So I'm going to do this in my calculator. I'm going to say 10 minus the square root of 12. And again, I have no desire to type all that information in, so I'm going to just use 10 minus root 12 in my calculator, and I get 6.535898385, and then I got to divide that by 4. Holy Hannah. And we said we're going 2 decimal places, so 1.63. Okay, so this is on an assignment or this is on a problem set. I want to check that I'm doing it correctly. I'm going to hop to my quadratic calculator. I'm going to put in the information. So my A value was 2, my B value was a negative 10, and my C value was a positive 11. And I got the right answers. Discriminant. And that's tomorrow's lesson. Yeah. Which way? This is left for me. Oh, you want me to go all the way back there? Yeah. Okay, we good? So what I would like you guys to do, example 3. Example 3, let's do our A, B's, and C's together. Nope. What's A? A is 1. Now B values are attached to the X. Do we have any X's? So what's B? And what's C? So tricky question, but not once you know what to do with it. So the B value is always attached to an X, so if you're missing something, then that just goes in as 0. And remember, just like factoring, everything has to be equal to 0 before you start using your quadratic formula. So I'm going to hit freeze on this, and you guys are going to get it set up. You guys are going to get set up. I'm going to get it set up, and we're going to see if we are the same way. Should I put a negative 0? No. No. Okay, let me know when you're ready. I just want you to set it up because you're not going to be able to go too far. Can I show you what I did? Are you guys ready? That's what I did. Yeah. How does yours look compared to mine? Same? Similar? I skipped writing the formula. I told you guys to do it and I skipped it. So here's a problem. So if I do this, this is like saying subtract a negative 20. So 0 subtract a positive 20 is going to leave me with a negative 20. Everybody agree with the math on that one? Now the question is can you take the square root of a negative number? No. So because this is negative, okay, so right there, we stop. If that number under the root sign is negative, we stop because it screws the whole question. We can't move forward with this because we can't square root a negative number. So it's not 0. Your answer is not 0. Your answer is no solution, no x-intercepts. Remember that we're always trying to throw this to a graph, right? So could you draw me a graph right now, a parabola, a quadratic function that has no x-intercepts? Yeah, you totally could, right? It's a real situation. You guys have graphed these before. Is that not a graph? Is that not a quadratic without any x-intercepts? So this might be the equation for this graph. It's not, by the way, but... because this is in vertex form. Where's the vertex in this? What's with the x? Is there anything attached to the x with brackets? So what number is that? 0. And then what's my other number? So there's my vertex. And which way does that graph open? Up. So if we were to graph this, this would be here. Does that have any roots to that function? No, it does not. So it's a very, like, people freak out when things don't work out, but this is a very plausible thing to happen in quadratics, that we just have no x-intercepts. We do this all the time. So this is my answer. If you leave it here with no explanation, if you don't have this, if you say no solution, no x-intercepts, whatever, then you get full marks. If you leave that part out, you don't. I don't know if you know that that's a problem, or if your calculator just gave you an error and you gave up. So this is essential, it's required, you must do it. Okay, where are we? Oh my goodness. Okay, 2 more examples. Would you guys like to do example 4 on your own? Okay, so you guys are going to do example 4 on your own, and I'm going to do example 4 while you guys are doing example 4, and then we'll make sure we have the same stuff. And we'll round to 2 decimals. Are you guys ready for me to show you? There's a few nods. There's a few people still working. How about I show you, and if you're still working, finish up. So that's what I got. Which one? Here? That's a 3. That doesn't even look like a 5. Not even. We need to upgrade your glasses. Come on. I'm kidding. Yeah, sometimes I get a little floppy when I'm rushing. So does yours look like mine? Sort of, kind of. And just to be sure, I'm going to check my quadratic solver. So A is 1, B is -4. Yep, that's what my quadratic solver tells me is correct. Hey, so I said this was the discriminant. It's in the equation. Can you find it in the equation? Where is it? So what's under the square root? So that discriminant's going to tell us a few things, and we're going to learn about that tomorrow. But that's what it's called, and that's why it's labeled D in this one. And this says, notice that this one says, not factorable over integers. All that's saying is that it won't use nice round numbers. You'll end up with decimals. So it couldn't factor it with nice numbers. So it's kind of a nice option. Yeah, like you can do inequalities in it if you want. You can do different functions. You can have it do the vertex and solve the function. If it's in vertex form, it does all the math. It shows you the answer. It doesn't show you the math to go with it. So I like it for solving quadratic equations is what I like it for. Okay, last one. Did you guys notice I haven't given you a positive b value yet? So maybe let's switch this one to a positive. Too bad. Too bad. You're too eager. Well, it's just I'd like you guys to see, just practice. If we change that to a positive one, when we do so A is 2, B is 6, C is -7. So when we put it into the formula, and remember that this variable has to match that variable. So if this is the letter P, then this has to be a letter P. Okay? It's a finicky thing, and you guys are like, Scallion, y'all know what I mean. But it's really important, like if you go on to do any math in university, they are super particular about these things. And that's what pre-cal is. It's all about the details. So it's a positive 6 this time. So what's it going to be in the formula? -6. So plus minus 6 squared minus 4 times A times C over 2 times 2. I almost forgot what 2 times 2 is. So I write it this way so I don't mess it up too much. I think as you get better with it, you could probably just pop this, like it's a negative here and a negative here, so you could change that directly to an add. But I think as we learn this, I don't think it hurts us to put that step in. So do you guys see how and where sometimes people mess up in these things? Like missing a negative is a really easy step to mess up on. Not squaring it's really easy to mess up on. Those are sort of things that are difficult. So I know some of you are going to ask me, ooh, that should be a -6. That's another thing that happens often. Those negatives get dropped when you do this. Sorry, I was talking. That should be a subtract. Here's the thing. People ask, Scallion, do I have to write this step? And the answer is no, you don't. Like if you want to just take it from this and then go right to the answers, you're more than welcome to do it. I write it out in the notes so you remember that it's actually two steps. All right, we're rounding to 2 decimal places, so that's 90. And if it requires 2 decimal places and it truncate means that we cut it off or it ends, you need to have 2, so you need to put that 0 in. Does that make sense to everybody? Like you're not going to just leave it at 0.9. Even if your calculator leaves it at 0.9, if I've told you 2 decimal places, it has to have the 0 attached to it. So if you're rushing through these, there's lots of places you can make silly errors. I don't think anybody has difficulty with this. I think sometimes it's just the rushing through to get your assignments done is where the problems pop up.